Hello everyone, how are you guys doing? I hope you're all doing amazing. Welcome to another video. Now, before starting this video, I want to acknowledge that I know I have not been making videos for the longest time and I'm really sorry for that. I want to be more consistent from the videos moving forward, and there was a lot going on where I couldn't prioritize making these videos, but now I finally set out to making these videos more regularly, and no matter what comes in life, I'll ensure that I make at least one video a day so that we keep going with this series and we are able to complete what we started and solve these 150 interview problems from LeetCode together. So without any further ado, let's get started with today's problem, which is H index. Now, in this problem, we are given an array of citations where citations I is the number of citations a researcher received on their ith paper. So basically, each index of that particular array represents a different paper, and the value on that particular index represents the number of citations that particular research paper has. Now, we have to find the h index of that researcher using that particular array. Now, what is h index? Now, here it is given that the h index is defined as the maximum value of h such that the given researcher has published at least h papers that have been cited at least h time, which basically means that if a particular researcher wants to have a h index of 2, he needs to have at least 2 research papers that have citations greater than equal to 2. So that is our problem. Now, let's take one of the examples and take it to straight to the whiteboard, and we'll see there how we can solve this. So let's take this particular example 30615, where the output is supposed to be 3. Now it is very straightforward why the output is supposed to be 3, as there are 3 research papers this particular researcher has that have a citation of greater than equal to 3. Now, why is the citation or the h index not equal to 4? Well, because there are not 4 papers that have greater than equal to 4 citations, and it qualifies to have a h index of 2, but the h index is supposed to be the maximum such value, which is given here. So it does qualify to have a h index of 2, but it also qualifies to have a h index of 3, and that's why our answer is 3. So let's take it to the whiteboard and try to formalize the problem a little bit. So you have this 30615, and you want to find the h index. Now, what is the brute force way of doing this problem? So basically, for each h index, we want to see whether the particular value qualifies or not. So we'll start from 0 and we'll see. So 0 h index is qualified by everyone, so we don't need to check anything for that. For one h index, we'll check that if any particular value in this array has the h index of has the number of citations as 1. So we see that 6 is one of those research papers. So or even 1 or even 3. So any of these research papers satisfies this particular condition, and the h index of 1 is qualified. So next we go to the h index of 2. So we see that we have 2 research papers that have greater than equal to 2 citations when we traverse the array, and we are able to say that the particular researcher qualifies to have a h index of 2. Now we do the same for 3, and we are able to see that there is one paper with greater than equal to 3 citations, second paper with greater than equal to 3 citations, and third paper also that has greater than equal to 3 citation, which again qualifies the metric to have a h index of 3, and this is satisfied. Now once we check for 4, we see that the particular condition is not satisfied and we fail here. So the final h index that we receive is 3. So for this particular solution, the runtime would be O of n into k, where n is the particular number of citations and k is our final h index that is qualified. So this is one of the solutions. Now, in this case, this solution would also work if you try to submit this solution, because if you look at the constraints, we have the number of research papers less than equal to 5,000 and the maximum number of citations to be 1,000. So in at max, you can have 5 into 10 to the power 6 operations, and that you can solve uh, easily. So O into n into k leads to at a max of 5 into 10 to the power 6 solutions, which would also work. So the brute force solution would also be submitted. But let's try to simplify the problem even further and see what is the redundant operation that we are doing that we can simplify and lead to a faster solution. So we have to think in accordance to uh, what is it that we are certain. We have to see both of the bottlenecks. So there are two basic bottlenecks that leads to a particular h index not being qualified. One is that what is the maximum number of citations a researcher has ever received. So what is the maximum number of citations he has received? So this in this case would be 6. So this researcher has received a maximum of 6 citations. So the h index can never be greater than equal to 6. Now, the second bottleneck is the number of research papers he has written for that particular researcher. Now, in this case, that would be 5. So, for this researcher, there cannot be a H index greater than equal to 5. So, we have to quantify both of these bottlenecks in such a way that we are able to get the final H index. Now, how can we go about doing that? So, one way to think about is that if we start the iterations from the maximum H index that we have ever received. So if we let's say sort this array in descending order, so we have 6, 5, 3, 1, 0. So this is sorted. Now we know that for this particular H index, this will satisfy all of these particular constraints till 6. So basically this will add up to all of these values. So all of these values will get increased by this research paper. So the research papers that have this particular number of citations would be increased by this value. So the maximum value can tell us the maximum H index we are ever going to receive in our paper. So this is how we are taking care of the citations bottleneck, where we are sorting them in descending order and saying that the maximum value is always taken care of. Now, the second thing that we have to take care of is the number of research papers. So for that, we say that if we see this index is 1, this index is 1, this is 2, and this is 3, and this is 4. So basically, at any index, if all of these values were satisfying a particular constitution, at max, you can have 5 as your H index. So which is basically that index plus 1. So in this case, if our first value has the number greater than its index value, index plus 1 value, that means that that particular index plus 1 is our H index. So what I mean is, when we see this first value in our descended ordering of this particular array, we see that there are 6 number of citations, and for this particular index to be the H index of that particular researcher, we need to have the number of citations to be greater than equal to that index plus 1. So in this case, 6 is greater than equal to 1, hence the H index of 1 is satisfied. Now when we go to the next iteration, we see that our index has gone to 1 and our citations have gone to 5. Now in this case, for this particular research paper to contribute to our H index, its citations should be greater than equal to its index plus 1. So the index plus 1 is equal to 2, and that should be greater than less than the number of citations, which it is. That's why the H index of 2 is also satisfied. Now when we go to this third value, we see that our citations is 3 and our index is 1. So greater than equal to 1 is just satisfied, and that's why 3 is also a valid citation, H index. But when we go to the case of 4, we have total research papers as 1, or the total number of citations is 1, and the paper should be 4 for this particular H index to be satisfied. So basically, if you think, what we are doing here is, by sorting the arrays in descending order, we are maintaining both of the bottleneck at once, and we are ensuring that both of the bottlenecks are satisfied for that particular index plus 1 to be the H index. Now in this case, the number of basically the citations are not enough for this particular condition to be satisfied. Now, why does this actually work? This is working because when we say that this previous condition was satisfied, we are already ensuring that we had the number of research papers that can satisfy this particular index. So that's why for the next iteration, it's going to be less than equal to that. So if it was satisfied in this condition, it must be also satisfied in this condition as well. So these papers already satisfy this condition if this is true. So that's why we are able to claim that when we say that 3 number of citations research paper just satisfy the third citation index, that is because we ensure that this particular index's value is less than the previous indices values, and that's why those indices will for sure satisfy this condition. That's why we have moved forward to that condition, and that's how we are maintaining everything. Now I hope it made sense. You can go through it again if it didn't. Otherwise, I'll recommend going through the code ones that we'll start with now, and I think that should cover up everything, and you will be able to see this picture better.
What the fuck are you talking about?
We are back at LeetCode, and let's try to code up the solution. So first of all, we have to sort the array in descending order, and after that we have to just traverse the array and keep checking that that particular index this value should be greater than equal to that index plus 1. And if that's the case, we'll keep updating our h index to be that particular index plus 1. And if that's not the case, we break the loop and we return whatever h index we have received till then. So let's first of all sort by descending order. So to sort by descending order in Golang, you can use the sort library, and in that you have a slice where you can input the particular slice or array. There, in this case, it's a slice because there is no fixed size, and you input that slice and you tell it what is the function by which you want to update or arrange the values. So in this case, we give a function where I and j are ints, and this basically represents that I is our previous value and j is our next value. And to compare between both of them, like what condition should be satisfied, so we basically say that our citations I should be greater than our citations j. So this should ensure that our citations are arranged in a descending order where citations I is always greater than citations j, ensuring that decreasing order. So after we have sorted the array, we'll just traverse the index and value, and let's just call it v, inside of our citation. And here we are just gonna return the value if we also have to maintain a h index actually. So let's just do that. And we're going to update the h index if that particular index plus 1 is less than value. So basically, let's just write it in this way, that will make more sense. Value should be greater than equal to index plus 1. And if that's the case, we are going to update our h index to be index plus 1. And if that's not the case, we are going to break the loop. And finally, we are going to return the h index. So this should just work. Let me try running this, ensuring we don't have any kind of coding errors. We do. Cannot use func ij int value of int as func return value. Oh, okay. So we need to return a bool in this. So the particular function that you are defining must return a bool. It's a condition. So this should work fine. There were other compilation errors as well. Let's just check them. Declared and not used I. Oh, I'm just using index. That's incorrect. This should be I. Just a naming error and undefined index. Yep, that should take care of both of those errors. And let's see. Cool. So the code is running, and now let's just try submitting it. We are okay with the runtime, so we basically sorted the array and then we just iterated it from the 0th index moving forward, so that we always update the h index to the value that satisfies this particular condition. So I hope that made sense after the code. And yeah, comment me down if you have any doubt. I'll try to clarify that in the comments down below. So make sure you comment, and let's just try submitting this. So drum rolls, please. Yeah. So the solution is accepted and it is working just fine. It beats 100% at runtime. Memory is 13.75%. I assume that is because the sort.slice operation itself takes some memory internally to sort these particular indices. And if we analyze the complexity, it comes out to be O and log n, which matches with our estimate or the way we build up the solution. So that works. Cool. If you have any doubts, please let me know in the comments down below. And please subscribe and like the video, and I'll try to be more consistent. See you another time. Bye bye.